Okay, here we go. Video number 7. Woo. We are getting to the end. And there won't be as much background information on this particular video or the next two, because I think we'll be finished with a couple more after this, because you have all of the rules that you need to implement for doing unit conversions for any level of difficulty. And so really these next 3 videos are going to be targeted on what are the structure of the different, oh, forgot to start my clock. What are the different structures that constitute a level 3 versus a level 4 and a level 5, but within any, you are still using the rules that you learned from level 1 and level 2. So let's begin here. So the focus of today's video is how do you do a level 3 unit conversion, or let's start with what does it look like. Now remember, before I was using letters like A and B to represent the different, I'll call them subunits of the unit, the overall unit structure. And so let's take a look at what does a level 3 unit look like. Now one form would look like this: A times B over C. So you'd have one unit times another unit up top of product, but then it would be divided by a third unit. Or we could, in a sense, have this flipped, and we would have a single unit in the numerator, and you would have 2 fundamental units being multiplied by each other in the denominator. So that's one possible structure. Now, one of the things that I hope you will understand when I make this comment is that if you had to do this type of unit conversion, this is simply like doing 3 individual level 1 unit conversions. But when you go to set them up, they will be structured one after the other. So you would just have a bunch of magic H's kind of strung out together. And remember, in the last video, one of my rules was, or one of the analogies was, you're not allowed to walk and chew gum at the same time, so you can only do 1 at a time. Now that you got 3, it's kind of like saying you're not allowed to walk, chew gum, and rub your stomach at the same time. Nor are you allowed to do 2 at the same time. You can only do 1 thing at a time. That same principle is still implemented here. There is no way for you to just slap together 1 thing and it takes care of your conversion. So this is one style of unit that you'll see. Now the other 2 styles, one of them would look like this. Let me move this over a little bit. Which looks like a product, but this first one will either be squared or cubed. Or kind of the reverse or mirror image of this would be these 2 things being multiplied, but the second unit is squared or cubed. So in this particular type of problem, this is like doing a level 1 and then doing a level 2 right after that in your structure. So again, when you're doing the conversion of A, which is being squared or cubed, you ignore the B, and then once you've set that conversion up, then you come back and ignore that, and then just tack on to the end of what you've already done the conversion of B to whatever you're supposed to take it to. Now the third type is taking this product form but making it a quotient form. So you'll either have the top thing being squared or cubed divided by the denominator to the first power, or the numerator will be the first power unit and the bottom will be the one that's squared or cubed. So what I would like to do, I mean, other than telling you this, it's all about practice. So what I would like to do here is, there is a level 3 worksheet at this site. What I would like to do is, now that I have it up here, I am not going to worry about doing a sample conversion for this first style. I'm going to do at least one. I'll try and do one example each of this second, the product style and the quotient style from the worksheet. And then I'll just leave it up to you to practice and be sure that you're comfortable with it. So hopefully you can understand when I say between level 3, level 4, and level 5, you're just going to be using the exact same rules that you learned between level 1 and level 2, but they're going to be more like grouped. And the overall unit structure will look a little bit more complicated, but if you remember, you can only do one thing at a time. You're either doing a level 1 conversion to completion or a level 2 conversion to completion, but it all gets tacked on together, so it'll start to look longer as we get to more complex units. Okay, so let's take a look at, from the level 3 worksheet, let's go with number 6. And number 6 says we are going to start with 3.45 e negative 4, and we are taking kilometers squared times nanoseconds and converting that to hectomiles squared times hours. All right, now I'm going to erase this level 3 thing here, and I'm going to do the multicolor thing again. I'm going to do orange and green this time. So we'll do green for the kilometers and orange for the time. So in order to get from kilometers to hectomiles, I'm going to need to go from kilometers to miles, and then I can go miles to hectomiles. And the thing that I'm going to have to remember is that this, as I set it up, is being squared, so I'm going to have to keep that in mind. And then for nanoseconds to hours, this is going to be pretty basic. I can get from nanoseconds to seconds and then seconds to hours. So now that I have that set up here, now I can start to bring the colors in. I can start with kilometers squared times nanoseconds. So again, because we read left to right, most people would attack the kilometers first. So I start my string of magic H's here. Now I need to get to hectomiles, so that means I need my kilometers to cancel, and I can convert that to whatever I want, but if I remember my kilometer mile conversion, I'm good to go there. And the value that I'll use them both, but I find a lot of people like to use this one. So that takes care of my kilometers, and if I square this, then both of these kilometers are now canceled. And now, at this point, I would be at miles squared. So the next thing I need to do is I need to get from miles to hectomiles, and this is being squared. This is where I tend to throw my squareds in there, or cubes, pretty quickly to make sure I don't forget them. Sometimes some people will set up the units first and then go back. Just remember, if you drop them, you're going to do the math wrong. Now here is a metric prefix conversion, or conversion factor. So hecto plus 2, mile has no prefix, so it's 0. So the bigger unit is the hecto. That means this gets the E, and the separation between them is 2. So I'm going to erase this now. And so now my miles squared has canceled, and I'm left with hectomiles squared, which is what I wanted. Now I have suspended, remember the walk, chew, gum analogy? I've suspended touching anything with the nanoseconds, but now that I'm done with the green part, now I can come back and do the orange part. And since both of these are in the numerator, I need them to cancel, so they have to be diagonal. Remember, critical term. I can convert that to seconds, and this does not have an exponent, so I'm not putting an exponent there. And this is another metric prefix conversion factor. Nano is -9, seconds is at 0, so the bigger one is seconds. The other side gets the E. 0 and -9 are 9 apart on a number line, so this would be a +9. So my nanoseconds now have canceled, and I'm left with seconds. And now I want to go from seconds, has to be diagonal, and I can do it to whatever I want, but I want it to go to hours. This would be a memorized one. 3,600 seconds in 1 hour. Seconds cancel, and now I have my hour. So at this point, we need to do the calculation. Okay? So now this is where different people will have different ways of processing this, but I have my approach, which I think is pretty rock solid, so that's why I'm throwing this one out as the one that I prefer. And I'm going to reiterate that this thing I'm going to do right now, I want to see this as part of your work when we do these unit conversions, because this gives me a window into how do you approach doing the math. I like to do it very discreetly, conversion magic H by magic H. So when I process this, I see 1 over 1.61, which for me means divide by the 1.61, and because it has the exponent of a 2, that's going to be squared. When I go over to the next one, I have 1 over E2, so that again means divide, and I divide by E2, and that is also squared. When I go over from there, I have another 1 over, so I get divided by E9, but no exponent this time because it's to the first power, and that last one I divide by 3,600. So now, if somebody's going, I have different ways that I would, I just want to see you write it out the way that you think is going to get you the right answer. So we start with 3.45 E -4. We divide by 1.61 squared, divide by E2 squared, divide by E9, and divide by 3,600, hit equal, and I am showing 3.70 E -21, and then to have this completely be correct, I got to have my units on at the end. Okay, now if you look at the answer that is on this particular worksheet, it gives 3.68 E -21, and what that would indicate to me is that when I prepared the key, I used a different kind of set of steps to go through this process, and as a result of that, I had a little wiggle room in that hundredths place in my leading number, and that is perfectly okay. So if you used, for example, the 0.62, you might end up with a slightly different value than the 3.70. Or if you forgot your kilometer to mile, I have some people who go kilometer to meter, meter to feet, feet to mile, and then continue. That could cause a little wiggling around in the room. But if your -21 does not match, then something went wrong there. Okay, so that's problem number 6 done. So now what we're going to do is we will take a look, because we have time, at one of the quotient ones. So let's see, which one do we want to do? Yeah, we'll go with that one. We'll go to the end of the worksheet and we'll do number 9. Okay, so let's get this erased. All right, so looking at number 9, it says we want to take 8.82 e negative 5 microminutes over liters cubed. Now remember, when you look at this on the worksheet, there'll be a slash. When you actually go to set this up, I almost want to say I demand that you write it this way so that you don't make that mistake of looking at a slash and thinking because they're both kind of next to each other that they're like both in the numerator, and then you put things wrong in your Magic H and you kind of put the right values in but you put them in the wrong place, you end up wrong. And we want to convert this to seconds over decagallons cubed. So here's our starting problem. So if we look at conceptually what we're going to do, I think people should be able to say, yeah, well, I'll go from microminute to minute, and then I can go from minute to second. And then for liters, I can go from liters to gallons, and then from gallons to decagallons. Perfect. So now we're all set to set things up. So we start with 8.82 e negative 5, but this time we will put the microminutes in green over liters cubed in orange. So now, back to the walk, chew, gum thing, we can only do one thing at a time. So, just for fun, I'm going to start with the, actually, you know what? I'm not. I'm going to go ahead and say, most people would say, look, I read left to right, top to bottom, so I'm going to start with the top unit. So, we start our Magic H's, so I'll color code this. This is the one to the first power, so this is literally like doing a level 1 conversion. So we make sure that our units are diagonal. Microminutes cancel. That gets us to minutes. Then we go minutes to seconds. All right, now we put values in. Micro is at -6. There's no prefix on minute there. So the bigger of the two is this one in the numerator. And then we have the E on the bottom, and 0 and -6 are 6 apart. So that gets e to the 6th there. Over here, 1 minute, 60 seconds. We are done with our green Magic H's. So now we go to the orange ones. So for the orange ones, we've got to go liter to gallon. And now because liter starts in the denominator, that means it has to go diagonal in the numerator here. And again, we can convert this to whatever we want. Let's see. Since we want to go to gallons, again, I remember this one. I think it's an easy one. And remember, this one's being cubed, so I'm going to put the cube there. Now, little detail here. Last year, I noticed when some people put exponents, they put them inside. Technically, I don't think that's the correct place to put them. The exponents need to go up outside your conversion factor because it's the conversion factor that is being cubed. That literally means that both things are being cubed inside the conversion factor, and I would have people who would put cubed and cubed. I would really suggest you follow this. Okay? And I'll probably point that out every so often to try and remind you because I think it's a better notation. So 1 gallon is 3.78 liters. So the liters cubed now cancel. And now we want to go gallon to decagallon, and this is being cubed, so we keep that there. Deca is at +1, gallon is at 0, so that means the bigger value is the decagallon, so it gets the 1 and the other side gets the E. 0 and 1 are only 1 apart, so we get that there. Our gallons cancel, and we have our seconds surviving and our decagallon cubed surviving, so we are good to go. So now we finish this by setting up our math. So with our starting value, we come to the first one. It's 1 over, that means divide. We divide by the thing that's on the bottom there, that's the E6. Then we go to the next one, it's a number over 1. When the value is on the top, that means multiply, so we multiply by 60. Then we go to the next one over, it's a number over 1, so that means multiply. So we multiply by 3.78, but this one is being raised to an exponent, so that exponent goes on that value. Then when we move over to the next one, it's a value over 1. So we are multiplying by this, and because it's being raised to an exponent, we get that exponent there. So now when we go to actually calculate this, we start with 8.82 e negative 5. We divide by E6 times by 60 times by 3.78. And this is where on my class calculators there is a cubed button. So you can just hit cubed and you're taken care of, times E1 cubed. And then when you hit equal, the number that pops up here is 2.86 e negative 4 micro, oh, sorry, I'm looking at the starting units, seconds over decagallons cubed. Okay, and the answer, this matches what's on the level 3 worksheet. So here's a little exposure to this. This is what the next 2 videos are going to look like, except we will be we will talk to you about the structure of level 3, or excuse me, level 4 and level 5. Maybe I'll do one example, because again, I didn't teach you any new rules here. The only thing was we combined pretty much all of the rules that you learned in level 1 and level 2, but instead of them being treated like totally separately, they're all kind of blended together. And again, if you remember that walk, chew gum, rub your tummy kind of analogy, and that you can only attack one thing at a time, so choose which one you want to attack and set that up properly, then come back and get the next thing that you need to take care of and just tack that on to what you've already done. This just becomes a string of magic H's. Some have exponents, some won't, but that all depends on the structure of the beginning units that you're dealing with. So, believe it or not, we're at about 24 minutes, and I don't think it'll be much longer on the next 2 videos, so it's getting better now because we've kind of front-loaded all of the rules. So your assignment is to practice the remaining problems on the level 3 worksheet and make sure that you can get the right answers. And if anything pops up, you're welcome to reach out to me or just save them till the first day of class. All right, thanks again, and we'll see you soon.